Yes.
although I have found BTH10 but B जैसे कि मैंने दूसरा कंसेप्ट अप्लाई करा तो उसके थ्रू नहीं आया सर BTH तो सिंपल तरीके से तो ये BTH10 आ गया मेरा लेकिन मैं दूसरा तरीका लगाया उससे नहीं आया मेरे सर
दूसरा तरीका मतलब
उससे ही मैंने ये क्या था सर जैसे सुपरपोजिशन वाला था सर जैसे कि एक मतलब दोनों ये अदर्स जो मतलब इंडिपेंडेंट सोर्सेज हैं उनको मतलब ओपन रखा और एक एक करके निकाला और उससे आई निकला तीनों आई को जोड़ लिया मैंने और रेजिस्टेंस ऑलरेडी मैंने RTH10 निकाल लिया था मल्टीप्लाइड कर दिया था VTH निकालने के लिए उससे नहीं आया सर ये
हाँ, लेकिन ये सुपरपोजिशन से भी हो जाएगा। I इंटू RTH क्यों किया आपने?
इसलिए क्या सर क्योंकि मतलब कोई रेजिस्टेंस तो इसमें जैसे कि AB के जो हम नेट
तो लेकिन जो
निकाले तो मैंने
RTH है,
उसमें दिखाया नहीं था
RTH इज समथिंग एल्स। VTH कभी भी I इंटू RTH के बराबर नहीं होता है।
बट सर यहाँ पर कोई रेजिस्टेंस जैसे कि वहाँ पर रेजिस्टेंस चला जाता था उसमें आई नहीं जाता था तो उसे छोड़ देते थे रेजिस्टेंस को जैसे BTH निकाल वहाँ पे आई निकालते थे सर लास्ट में
सुपरपोजिशन से
BTH
आपको
आता था
क्या
सर
करना है? अगर आप सुपरपोजिशन यूज कर रहे हो इसमें, what you can do is you can find out current in this path, say for example। ऐसे आप करंट यहाँ पे भी निकाल सकते हैं। अगर आपको करंट यहाँ पे भी इस पाथ में भी पता है, आपको करंट इस पाथ में भी पता है, you can find out the voltage at this point, you can find out the voltage at this point। तो VAB आपका डिफरेंस ऑफ द टू वोल्टेजेस है, VTH। वो हो जाएगा सुपरपोजिशन से भी, उसमें ऐसा if you apply it like that।
Sir, in this, which is the variable voltage? Like in the previous question, we used to take a variable voltage which we used to remove in the first step.
Variable
So in
load,
this variable load, yeah.
load will be actually across this A and B। फाइन, तो यहाँ पे कोई वेरिएबल लोड होगा, ये ऑलरेडी ओपन करके रखा है इसने। तो मोस्ट ऑफ द क्वेश्चंस when you will be asked, instead of putting a variable load there, it will already be kept open circuit for you, so that you can apply anything, any kind of load at that particular open circuited end। इस केस में आपको जैसे बताया गया था, find Thevenin's equivalent circuit across the points A and B। so A and B के across actually आपका load apply हो जाता है यहाँ पे, variable load। now if we solve this, RTH तो simple है। ये 10 ohms आ रहा है यहाँ पे, ये 10 ohms आ रहा है, while turning off all these resistance, voltage sources and current sources। ये 20 और 20 ohms जो है ये पैरेलल में है, तो that will also come out to be 10 ohms। और यहाँ से भी आपका 10 ohms है। This is simple Wheatstone bridge, you can say a bridge concept। That means you can either solve it by considering these 10 ohm resistance, you can redraw this circuit, it's something like this। This is your point A, this is your point B, these all resistance are 10 ohms। You can consider this as a delta, convert it into star, and find, then you will have two resistances in series, in the upper leg, in the lower leg also two resistances in series, combine them, then those resistances will be in parallel along with another resistance in series। तो आपकी जो resistance मिल जाएगी, you can find that out। और from the bridge concept you can simply say that since this is a balanced bridge, यहाँ से जो current flow हो रही होगी that will be zero। If current flowing through this 10 ohm resistor, that is the middle leg, is zero, we can neglect this portion, so you are left with 10 10 at the top, 10 10 at the bottom। so if you calculate this resistance will be equal to 10 ohms, that is RTH। then talking about VTH, यहाँ पे 10 ओम है, 10 ओम 30 volts. This is 5 ampere and 10 ohms in between. What we can do is we can use source transformation here. By source transformation, we can simply say this is 10 ohm resistance in series with 10 into 5 ampere current, that is 50 volt voltage source. We can use source transformation. यहाँ पे फिर 20 ohm था, यहाँ से भी 20 ohm है, यहाँ पे एक voltage source है 20 volts का, माइनस प्लस ऐसे, और यहाँ से भी एक रेजिस्टेंस है 10 ohms की. We can apply mesh analysis. You have 3 meshes, I1, I2 and I3. So by using KVL in mesh number 1, this is loop 1, this is loop 2. Yes.
How can we write here in between this line 50 volt?
5 ampere current source is in parallel with 10 ohm resistance. So we can use source transformation here. Source transformation जैसे मैंने आपको बताया, you can convert a current source into a voltage source by multiplying resistance. Resistance V is equal to I into R. So 5 amperes into 10 ohms is 50 volts. But जो resistance है अब वो series में आएगी with the voltage source instead of being in parallel. तो आपके पास 3 loops हो गए. KVL in loop 1. By applying KVL in loop 1, you have 30 is equal to, mute your microphones, 10 I1 plus 10 I1 plus 10 I1 minus I3 plus 50. Fine. Which implies 30 I1 minus 10 I3 is equal to minus 20. Equation number 1. KVL in loop 2. By
सर हम लोगों ने तो ये शॉर्ट कर दिया था बीच वाला.
short.
हाँ सर, वो मतलब वो दे रहा था ना, मतलब 5 एम्पियर इसके पैरेलल में जा रही थी 10 ओम के, ठीक है, इसे मतलब माना ही नहीं था उसको, पूरी लूप को ले गया था, इस वाली बड़ी वाली लूप ले ली थी हम लोगों ने.
वैसे भी कर सकते हो, मैं you can do it n number of ways. आपकी मर्जी है कैसे करना है. So यहाँ पे जो 20I2 है वो किसके बराबर है, 20I2 minus 20 के बराबर है. KVL in loop 2, 20I2 minus I3 plus 20I2 is equal to minus 20, which implies 40I2 minus 20I3 is equal to minus 20. ये plus 20 है यहाँ पे. And KVL in loop 3, let us start from this resistance, 20 I3 minus I2 plus 10 I3 minus 50 plus 10 I3 minus I1 is equal to 0, which implies minus 10 I1 minus 20 I2 plus 20, 30, 40 I3 is equal to 50. ये आपकी third equation हो गई. So from these three equations you can see that I1, by solving these three equations, I1, I2, I3 will be equal to 30, 0, minus 10, 0, 40, minus 20, minus 10, minus 20, 40 इसका inverse into minus 20, 20 and 50.
एक्सक्यूज मी सर.
Yes.
सर वहाँ पे जो हम लोग ने वो जो एक सर्किट था जिसमें 5 एम्पियर करंट बह रहा था, उसको हम एक और मेश मान सकते हैं ना, उसको भी मेश मान के सॉल्व कर सकते हैं.
हाँ, आप सिंप्लीफाई भी कर सकते हो, जैसे मैंने किया उससे सिंप्लीफाई हो गया.
हाँ सर, तो वहाँ से क्या होगा कि हमको I2 का वैल्यू पता रहेगा 5 एम्पियर, तो वहाँ से इजीली सॉल्व होके निकल जाता है.
जैसे मैंने आपको कहा, यू कैन डू इट अ नंबर ऑफ वेज. मुझे लगा ऐसे इजी हो जाएगा. अगर आपको लग रहा है कि वैसे इजी हो जाएगा तो आप चेक कर सकते हो.
ओके सर.
So on solving this matrix, I am getting I1, I2, I3 equal to 0, 1.5, 2.0 amperes. Fine. By the values of I1, I2 and I. Yes.
So can we use scientific calculator in exam also?
हाँ हाँ. So I1, I2, I3 मुझे पता चला 0, 1.5 and 2.0. So यहाँ से जो current है at this point, that is 0 amperes, and I2 at this point, इस loop में जो current है, that is I3, that is 2 amperes. So now we need to find out what is the potential difference at these two nodes. Fine. Once we have the potential difference at these two nodes, then we can say what is VAB equal to, what is VTH equal to. So what will be VA at this point? What will be VA equal to? That will simply be equal to 30 volts. क्योंकि यहाँ से करंट 0 एम्पेयर फ्लो हो रही है, तो इस रेजिस्टेंस में ड्रॉप 0 है और नीचे से 30 वोल्ट है आपका, तो डायरेक्टली वी कैन से VA is equal to 30 volts. And as far as VB is concerned, VB is the potential drop in this resistance, that is 2 into 10, that is 20 volts. Now what is VTH? VTH is VA minus VB, that is 30 minus 20, that is equal to 10 volts. So is this fine?
Yes, sir.
Okay, so let's move on. Uh, we have to study case number 2, wherein we have with a dependent source. Say for example, we have this circuit. Steps तो वही है. You have to find out RTH, you have to find out VTH, and then you can redraw your Thevenin's equivalent. बट अब इसमें RTH कैसे निकालना है वो थोड़ा सा डिफरेंट है, वो हम देख लेंगे using an example. So you have a 5 ampere current source here, 4 ohm resistance, you have a 2 ohm resistance, you have minus plus 2Vx, you have a dependable voltage source here, there is a 2 ohm resistance, there is a 6 ohm resistance here. You have to find out Thevenin's equivalent uh, uh, across this open terminal and that is AB. Okay? So there would have been some variable load at this very point. So first step, we have to find out RTH. For that we need to uh, turn off all the independent sources. So when we turn off all independent sources, 5 ohm current source that will be replaced by an open circuit. So you have a 4 ohm resistance here, you have a 2 ohm resistance here, you have a 6 ohm resistance here, और ये जो Vx voltage है ये across this this is the voltage across this 4 ohm resistance. There is a 2 ohm resistor as well, and you have this dependent voltage source as it is 2Vx, where Vx is the voltage across this terminal. Now can you find the equivalent resistance of this circuit directly?
5 ohms.
How do you say it's 5 ohms?
Not directly.
It is not, by the way, it's not 5 ohms.
Because it will be 5 ohm na? Because in dependent source is in resistance 3 in the given question.
That is not given to you in the question that dependent source is resistance free. So this dependent source will also contribute some resistance. So you have to actually find out the equivalent resistance of this circuit. Now you cannot directly, अब यहाँ पे आप 2 और 4 को directly in series ऐसे तो नहीं कर सकते. You have one source there that you need to solve. And how you do this? इसके दो प्रोसीजर्स है. ये जो ओपन टर्मिनल एंड है, यहाँ पे आप या तो वोल्टेज सोर्स और अ करंट सोर्स, यू कैन अप्लाई a voltage source or a current source at this particular point. That depends up to you, and you can take uh, any value of voltage of this voltage source. You can take 5 volts, 10 volts, 20 volts, or it's normally easier to solve with if you take 1 volt. So what we do is we are applying a 1 volt voltage source here. We have to actually find out equivalent resistance at this particular end. So by applying a voltage source, what we'll be doing is we'll be finding out current that will be flowing from this end. Fine. So once we know the current and we have already applied a 1 volt source, we can directly get R equivalent will be equal to V divided by I. Or you could have used a current source as well. You could have used a current source of, say for example, 1 ampere. In that case, what, instead of finding current I here, you would find out the voltage across this particular end, and then you could have multiplied, you could have again you could have got R equivalent using the formula V divided by I. There was an open end here. This was open here, and we have to calculate the net equivalent resistance by looking at into this end. We cannot do that for this particular circuit directly because of the presence of this dependent voltage source in this circuit. So what we can do is we can apply any amount of voltage to this circuit and find out the current being supplied by this voltage source. So whatever volt current value will be deriving from that, we'll be able to then find out the resistance at this particular end. ठीक है, तो मैंने यहाँ पे 1 वोल्ट का एक वोल्टेज सोर्स लगा लिया है. So let us find out the current that is flowing into the system. So you can now solve this circuit, and by applying mesh analysis, this becomes a little bit, इसमें थोड़ी बहुत मेहनत करनी है to find out R equivalent. We have 3 meshes here. This is current I1, this is current, say for example, I2, and let this be current here, I3. So KVL in loop number 1. Yes, 4I1 plus 2I1 minus 2I3 plus 6I1 minus 6I2 is equal to 0. This is the KVL when applied to loop number 1. This is loop number 2. This is loop number 3. So this is 4, 6, 12I1 minus 6I2 minus 2I3 is equal to 0, or you can say 6I1 minus 3I2 minus I3 is equal to 0. ये आपकी इक्वेशन नंबर 1 हो गई. KVL in loop number 2. Starting from the 6 ohm resistance, 6I2 minus 6I1 plus 2I2 plus 1 volt is equal to 0, which implies 6I1 minus 8I2 is equal to 1. ये आपकी इक्वेशन नंबर 2 हो गई. KVL in loop number 3. KVL in loop number 3, we have 2Vx equal to 2Is I3 minus 2Is I1, where Vx is the voltage across this 4 ohm resistor. That's actually 4I1. 4I1 is equal to 2I3 minus 2I1, which implies 8I1, 10I1 minus 2I3 is equal to 0. ये आपकी इक्वेशन नंबर 3 हो गई. So you have 3 equations. So I1, I2, I3 will be equal to 6 minus 3 minus 1, 6 minus 8, 0, 10, 0 minus 2, इसका inverse, and on the right hand side you have 0, 1 and 0.
Sir, I1 0.3, sir, I2 0.1.
0.3, 0.1 and 1.5.
Yes, sir.
So this is I1, I2 and I3. Now we are actually only concerned with I2. I2 is equal to my I. We are actually interested in this current I that is flowing from here. I is equal to minus I2, which means what we are getting, minus 0.1 volts here. प्लस माइनस में कहीं पे गड़बड़ हो गया.
तो ये 2vx वाली इक्वेशन में गलत है.
2vx is equal to
नहीं आएगा सर. क्वेश्चन नंबर 2 में देखिए सर.
6i2 minus 6i1 plus 2i2 plus 1
आएगा -6i1 plus 8i2.
minus 6i1 plus 8i2 is equal to minus 1. तो वो हो गया ना 6i1 minus 8i2 is equal to 1.
सर थर्ड लूप.
थर्ड लूप नहीं, थर्ड लूप भी ठीक है. minus 2vx plus 2i3 minus 2i1 is equal to 0. That means 2i3 minus 2i1 is equal to 2vx. What is wrong with this? Hmm?
सर ये इक्वेशन तो तीनों ही ठीक है, मेरा भी ऐसे ही आ रहा है।
सर I3 1/6, I2 1/30 और I3
Inverse 6 minus 3 minus 1, 6 minus 8, 0. 6 minus 3 minus 1. 6 minus 8, 0. 10, 0 minus 2. Yes.
सर I2 0.125 आ रहा है।
कैसे? मतलब मैट्रिक्स आपका यही आ रहा है?
equals to 1/6 आ रहा है। I1 equals to 1/6। सर यही आ रहा है।
ये इक्वेशन भी ठीक है, इस इक्वेशन में भी कोई गड़बड़ नहीं है। ऑल द इक्वेशंस आर फाइन, प्लस माइनस में भी ठीक ही है। Vx is 4i1.
I1 I2 दोनों की वैल्यू सही है सर। I3 1/6 आ रहा है।
i3 मुझे i3 के साथ वैसे भी कुछ नहीं है। i2 का वैल्यू जो बुक पे दिया है, जो मैंने i2 लिया है, i2 the book is
I1 0.3, I2 0.1 और I3 1.5।
बुक पे आंसर ये है, but we are getting this thing and I don't think कि हमारे although KVL equations तो सेम दे रहा है।
Vx देखो ना सर, Vx की वैल्यू नेगेटिव में आएगी। यस सर।
Vx is equal to minus 4i1. हाँ, minus 4i1 यही है। minus 8 minus 8 minus ये हो जाएगा minus 6 minus 2i3 is equal to 0. ये यहाँ पे था minus 6 0 minus 2. So if we substitute this now,
सर ये वाली लूप है जो फर्स्ट है, जो I1 इसमें जा रहा है, उसमें इक्वेशन उसकी लिखेंगे माइनस के 4i1 माइनस के 2i1 माइनस I3 माइनस के 6i1। तो इसका I1 और I3 में रिलेशन आ रहा है सर मेरा। I1 इक्वल टू
बस इसमें ये था Vx minus 4i1 था और बस माइनस वहाँ पे रह गया था, that was the problem. बाकी अब ठीक है, minus 0.0556 minus 0.1667 and 0.1667. So we are getting I2 equal to minus 0.1667. जो हमारा I है that is minus I2 which is equal to 0.1667. So we have found out current I flowing in the circuit. We know the voltage that we have applied 1 volts. So RTH will therefore be equal to, यहाँ पे मैं लिख रहा हूँ 1 volts divided by 0.1667, that is 6 ohms. ठीक है, तो ये तो आपका RTH वाला पार्ट हो गया। VTH वाला पार्ट then you have to get back to your original circuit. 5 ampere current source driving So you have to find out the voltage at this terminal, that is VTH. So you have again three meshes, 1, 2 and 3. Fine. This is loop 1, loop 2, loop number 3. From loop 1 you can directly write I1 is equal to 5 amperes. From loop 2, by applying KVL, once we apply KVL, what we have here is 4I2 minus I1. I1 is 5 amperes plus 2I2 minus I3 plus 6I2 is equal to 0, which implies 4, 6, 12I2 minus 2I3 is equal to 20. This is equation number 1. From loop 3, using KVL again, you have 2Vx equal to 2I3 minus I2. Where Vx is the voltage, Vx यहाँ पे अब जो voltage है, that is 4 times I1 minus I2. Where I1 is, I have already found that it is equal to 5 amperes. 5I minus I2 is equal to 2I3 minus 2I2. This is 4, 5, 20, 40 minus 8I2 is equal to 2I3 minus 2I2. ये 8 is side, this will be 6I2 plus 2I3 is equal to 40. This is equation number 2. So solving equation number 1 and 2, we get I2 and I3 equal to 12 minus 2, 6, 2, इसका inverse multiplied with 20, 40.
Sir, I3 is 10 by 3 and I2 is 15 by 9.
So I2, I3 you are getting by solving this matrix. 3.33 and 10.
Sir, I2 3.33 और I3 10.
ठीक. Then VTH किसके बराबर है? यहाँ पे VTH will be simply the voltage across this terminal. VTH will be 6 into I2. I2 किसके बराबर है? 3.33. 6 into 3.33, that is 20 volts. So ये हमारी एक न्यूमेरिकल हो गई. So we have a dependent voltage source now. The only thing here is to find out RTH. What you have to do is you have to apply either a current source or a voltage source, then find out the current at this particular end and the voltage at this particular end to find out RTH. VTH तो normally जैसे निकालते हैं वैसे ही निकालना है. You have to obtain the Thevenin's equivalent of this particular circuit. So again, to find out RTH, turn off all the independent voltage sources. So you'll be left with 5 ohm resistor here, 6 ohm resistor to short हो गया, dependent voltage sources ऐसे ही 3, 4, 3, 4 Ix is the current flowing in this circuit, 5 Ix is the current source here, dependent current source here. Now to find out RTH at this end, what you can do is you can apply a voltage source or a current source at this particular point. Let us assume we apply a current source, we apply a 1 ampere current source here. ठीक है, हम क्या करेंगे, हम वोल्टेज निकालेंगे इस पर्टिकुलर एंड पे ताकि हमें RTH का वैल्यू पता चल जाए. So we applied a 1 ampere current source here. And let us apply nodal analysis. This is node number 1. This is node number 2. Fine. So at node 1, by KCL, what we have is, let the voltage here be V1, voltage here be V2. Let the current coming from here is I1. यहाँ से तो करंट 5ix आ रही है, यहाँ से ix जा रही है. Let this be I1 and let the current flowing here be I2. यहाँ से जो करंट आ रही है that is 1 ampere. KCL at node 1 means I1 plus 5ix is equal to ix, which implies what is I1, but I1 is simply V1 divided by minus V1 divided by 5 ohm. It is I1 is the current that is flowing from a potential of 0 to a potential of V1 to a 5 ohm resistance. So it will be minus V1 divided by 5 plus 5 times Ix is equal to Ix is the current that is flowing from a potential of V1 to a potential of V2 to a resistance of 3 ohms. और ये जो Ix है इसको भी हम इसी से रिप्लेस करेंगे. So this will be, this total actually 6 Ix. Yes. I1 is current flowing from a potential of what? I1 की direction के हिसाब से I1 is the current flowing from a 0 volt potential, that is the reference node, to a potential of V1 through the 5 ohm resistance. So this is 0 minus V1 divided by 5 plus this is 5ix, that becomes 4ix equal to 0. Instead of ix, what we will write is V1 minus V2 divided by 3 now. V1 minus V2 divided by 3. So this is minus V1 by 5 plus 4V1 by 3 minus 4V2 by 3 equal to 0. Minus 3V1 minus 17V1 divided by 15 minus 4 by 3V2 is equal to 0. यह आपकी इक्वेशन नंबर 1 हो गई. At node 2, KCL, node 2 पे KCL लगा के Ix plus 1 ampere is equal to I2, where Ix is what? V1 minus V2 divided by 3 plus 1 to ऐसे I2 is what? I2 is V2 minus 0 divided by 4. ठीक है, अगर मैंने I1 ऐसे लिया होता, then I1 would have been V1 divided by 5. Since I'm taking I1 like this, it is minus V1 divided by 5. So this is V1 by 3 minus V2 by 3 minus V2 by 4 is equal to minus 1, which implies V1 by 3 minus 7 V2 by 12 is equal to minus 1. ये आपकी equation number 2 हो गई. Equation 1 and 2 gives us what? It gives us V1 V2 is equal to 17 by 15 minus 4 by 3 1 by 3 minus 7 by 12 इसका inverse into 0 minus 1. So this matrix, what will be V1 V2?
So V1 equals to 6.15 and V2 equals to 5.3.
6.15. V2 is
5.23.
5.23. 5.33.
सर V1 होगा 6.1.
6 point
5.
V2 अब RTH किसके बराबर है? RTH is simply current source, that is 1 ampere into यहाँ पे जो voltage है, यहाँ पे क्या voltage है? वो V2 है. V is equal to V2. V2 आपका 5 point R is equal to V divided by I. Sorry. V2 divided by the current source that you have applied. ये 5.33 आना चाहिए, not 5.23. Divided by 1, that is 5.33 ohms.
सर V2 5.2 V2 is 5.23.
Yes, sir. 5.2.
V1 is 6.15. Yes.
क्लास में देखे हैं 15 मिनट. Yes, sir. You have just finishing the class. But RTH जो है, that is coming out to be 444.4 milliohms. That is actually 0.4 ohms. तो ना तो ये है ना तो वो है. V2 0.4 आना चाहिए. Again I1 plus 5ix is equal to ix. I1 is equal to 4ix. I1 plus 4x x V1 minus V2 by 3. I1 is 0.1 minus V1 by 5 plus 4 V1 by 3 minus 4 V2 by 3 minus
हम तो कैलकुलेटर से सॉल्व किए हैं.
क्या चीज?
सर साइड पे कैलकुलेटर सॉल्व किया था सर.
1 minute, let me check this. 17/15. ऐसे तो ये ठीक आ रहा है 6.15 1.23 बट आना तो नहीं चाहिए। ix plus 1 is equal to I2. Ix is V1 minus V2 divided by 3. I see V2, I2 is V2 divided by 4. V1 by 3 minus V2 by 3 minus V2 by 4 is equal to minus 1. V1 by 3 minus 4 minus 7 V2 by 12. इक्वेशंस तो यही है, इक्वेशंस में कहीं पे प्लस माइनस में लग रहा है आपको?
इक्वेशन सारा सही है सर।
ओके ठीक है, हमारा ठीक है। मैंने एक्चुअली क्वेश्चन ही गलत लिख दिया है। यहाँ पे 1.5 ix है। We have now done it for 5 ix. Let us continue with it. So VTH हमारा क्या मिलेगा? RTH हमारा V2 डिवाइडेड बाय जो करंट सोर्स हमने लगाया था 1 एम्पेयर करंट सोर्स. So this is 5.23 divided by 1. So that is 5.23 ohms. Fine. So we are continuing with this 5 ix यहाँ पे. You can then check it for 1.5 ix as well. तो ये आपका RTH हो गया. ऐसे VTH निकालने के लिए plus minus 6 volts 5 ohms 5 ix 3 4 now we have to find out VTH, that is this open circuit voltage. What will be VTH here? This is one super mesh. So by applying KVL to super mesh, KVL to super mesh, we get 6 volts is equal to, if this is current I1 here, this is current I2 here, fine. 6 is equal to 5 I1 plus 3, actually IX है, 3 I2 plus 4 I2, which implies 6 is equal to 5 I1 plus 7 I2. This is equation number 1. Also from this particular branch, I1 I2 minus I1 is equal to 5 IX, where IX is what? IX is nothing but I2 in this particular circuit. 5 I2, which implies I1 plus 4 I2 is equal to 0. ये आपकी equation number 2 हो गई. So 1 and 2 you have I1 I2 is equal to 5 7 1 4 inverse 6 0. तो I1 I2 किसके बराबर आ रहा है?
इधर I2 आ रहा है -6/13 एंड I1 आ रहा है 24/13.
24/13 minus 6/13.
13.
I2 is minus 6 by 13. Now VTH is what? It is voltage across this 4 ohm resistor. That is 4 into the current that's flowing through this I2. 4 into minus 6 by 13. Fine. So minus 24 by 13 volts. So we have done this question. Original question क्या था? यहाँ पे 1.5x था, 1.5ix था, but मैंने 5ix लिख दिया था. अगर आप यहाँ पे 1.5ix लिखोगे, then you should get these things. You can check now this for 1.5ix. VTH आपको 5.33 volts आएगा, RTH आपको 444.4 milliohms आएगा. ठीक है, for 1.5ix. We are done for 5ix. For 5ix we are getting RTH equal to this and VTH equal to minus 24 divided by 13 volts. Okay, so we'll wrap it up there today. So we'll continue tomorrow.
Okay, sir. Thank you, sir.
आज डेट क्या है? ठीक है. ओके, तो 5ix के लिए तो हमने कर लिया, 1.5ix के लिए ये चेक कर लेना. फाइन, यू कैन लीव.